A great good morning once again to all of you. I am your course instructor, Khushwant Fatnani. We are taking revision lecture for JEE and NEET, right? And in the series of the same, let us proceed by starting the class for the day. We'll have a short prayer and meditation. I request all of you to please join your hands, close your eyes, bring a smile on your face, and let's start. Deep breaths strengthen your mind and your body. They relax you and make you more peaceful and therefore more absorbing towards knowledge and more focused. Count one. Take a deep breath in and a deep breath out. Count two. Deep breath in and deep breath out. Count three. Breathe in once again and breathe out. We'll pray all together. It's said that prayers have immense power. It is not just hard work, but hard work and destiny that bring somebody any result they desire. And prayer has the power to influence our destiny. So let us pray together. After me, kindly repeat in your own places, wherever you are, with a smile on the face and faith in your heart. Dear God, we are your children. We thank you for all the blessings of life, for this life and everything amazing that you have given us. For every breath, I am grateful. For every support, I am grateful. Thank you for such good health, wealth, and wisdom. Your favor and your grace is upon me, my health, wealth, hobbies, education, career, finances, my family. Thank you, God. I thank you in advance for assisting me in clearing JEE 2020 and NEET 2020 in flying colors. I thank you that I have got admission into the college of my dreams in the year 2020 and that I have become great doctor, a great engineer in the times to come. Thank you in advance, God. Thank you in advance. With a broad smile on your face, faith in your heart, peace in your mind, open your eyes slowly and steadily. So I think one of you had requested in yesterday's class to take some questions based on pulley. Let us cover that concept and the remaining concept from yesterday's class so that we can have a basic understanding of a better understanding of the previous chapters. So today what we'll do, today we'll solve some more questions from laws of motion and work power energy, the ones which were remaining yesterday. So we'll take those questions up, question number 12 to question number 17 in yesterday's assignment class. And then we are going to take up the concept of pulley. How are questions based on pulley asked? And how do you solve them? We'll learn that technique. Then we'll take up the chapter rotational motion and system of particles, or the other way around, system of particles and rotational motion. So class, let us start off. I want one of you to help me with the questions. So today let us take Monica. So Monica, can you please read the question number 12 for all of us? Yes, go ahead. Yes, Monica.
Block M is placed on a smooth wedge.
Just a minute, Monica, just 1 minute. Yes, go ahead. Go ahead, Monica. Yeah.
Block M is placed on a smooth wedge. What force F should be applied on the smooth wedge, that is 4-meter wedge, 4 and mass wedge, so that the block does not slide over it?
Right. So we have, class, we have been given with a wedge, or basically an inclined plane, right, which has been kept on a horizontal base, right? All the surfaces are smooth, right? All the surfaces are smooth. That means there is no friction anywhere. Now, here on the wedge, we are keeping another block of mass m, right? This mass of the capital block is given as 4m. So let us take capital M given as 4m. Now, what is being done is a force F is being applied in the rightward direction, on this block. So let's say a force F is applied over here in this pattern. Let us say we name it as by F. Now this angle of the wedge is given as theta. What we experience is, as the block is pulled towards right, this small, or the wedge is pulled towards right, this block does not fall. See, such a magic. This does not fall. Why? The very first question which comes to mind is why. There is definitely something happening which is preventing this block from falling, right? Physics is a subject which always kind of helps you answer the questions like these. Why, if something is happening, why is it happening? And link a logical reasoning to the same, right? So what is being asked in the question? The force, value of force, right, Monica? Yes. So how to tackle such a question, Monica? Let us give some hint, or maybe some approach. How would you have solved it? Yes. What is happening first of all? Why is the block not falling? Yes, Monica.
First, we'll make the free body diagram of this question.
Okay, we'll make a free body diagram of this question. All right, we'll do that. Let us first of all make a free body diagram of just the small block M. But first of all, tell me one thing, Monica. When the entire system is moving towards right because of the application of force on the wedge, so when I'm saying wedge, I mean this triangular body. Why do you think is the this block not falling? Why? What's the reason? What is the magic that is happening? Yeah, tell me, Monica. Any idea?
So,
All of us have read something. in the chapter. It's called pseudo force. What is
Pseudo force.
pseudo force? What is pseudo force? So pseudo force is a very special kind of force, and we all experience it in the everyday life. Let us say this is the platform or this is the base of a train, right? You're in a train and you're traveling in it. This is you on a train, right? Or me, any one of us, right? All of us are on a train. The train is moving, right? So this base is moving. Suddenly it stops. What do you feel? You get a jerk in the forward direction, right? If the train stops, and the reverse happens when the train suddenly starts moving, right? Suppose the train was steady and suddenly the train starts moving. Similarly, when you're on a bus, the bus suddenly starts moving, you feel a jerk backwards, right? What does this mean? Why are you feeling a jerk backwards? Because there is some kind of force which becomes active on you whenever that either the train was stopped and it starts moving in the forward direction, or the train was already moving and it stops. Therefore, you get a jerk in the forward direction, right? So what happens is, suppose initially the velocity of the train was zero, right? It started suddenly moving in the forward direction. That means it got an acceleration in the forward direction. This acceleration in the forward direction, this acceleration in the forward direction led to an acceleration acting upon you in the backward direction. And this acceleration acting on a person of mass m is called is can be called as basically a force which is equal to ma just acting in the backward direction. I will repeat what is happening. So, when the engine of the train or the vehicle is applying a force, suppose F naught in the forward direction, how much should be the force, Monica? What is the value of force given as? Any given force is given as on any body. How much is it given as? Total mass upon into acceleration, right? Right? So if the train is carrying you and the weight of the train, total mass should be m plus m, right? And an acceleration in the forward direction. Correct, Monica? Right? Now, what about the person on the train? He is experiencing an acceleration in the backward direction, which is same as the acceleration of the train. So, in order to make the matters clear, I'll introduce you all once again to a force which is called as pseudo force. Pseudo force concept is very simple. You will have something called as a frame, right? Or an accelerated frame. This is an accelerated frame. Everyone, please take a note with you. You get many questions from this concept every year in both examinations, NEET as well as JEE. So such a question is very much probable, right, in this year also, right? This concept is very probable. What is the concept? That you will have a frame which is accelerated. So this is a frame which is accelerated. It has some acceleration in the forward direction, right? And there is somebody who is standing on this frame. Somebody who is standing on this frame. What happens is, this person standing on the frame experiences a backward force, this way, right? And suppose the mass of the person is m, mass of the platform which is moving ahead or the frame which is moving ahead is capital M. So the acceleration experienced by this man is same, just that it is in the opposite direction. So when I talk about force, so the net force, so when I talk about force, the net force, the net force acting on the system, Net force acting on the system is its total mass into total acceleration, right? Of course, we all know this, that net mass into net acceleration. Now, therefore, we will have F. Suppose F is the force acting on the system, right? So F net will be equal to total mass, that is mass of the platform and mass of the man into acceleration. First thing. Now, what will happen? This man will also experience a force in the backward direction. Let that be F naught. So we will write this F naught, or force acting on the man, will be given as F naught m times of acceleration, just that it is in the opposite direction. See, what is the connecting link? This acceleration is the connecting link. If the system is gaining an acceleration in the forward direction, this man on the train is experiencing a backward directed acceleration. I will repeat. If the entire system is given an acceleration a in the forward direction, the man on the system, this accelerated system, right? So this is an accelerated system. So this man is experiencing the same acceleration, just that it is in the backward direction. So same acceleration as the system, but in opposite direction. In opposite direction. So this is what pseudo force looks like, right? So the force being experienced by the man will be called as pseudo force. So the force being experienced by the man who is on a non-inertial frame of reference or accelerated frame, right? That force experienced by the man in the backward direction will be called as pseudo force, right? Okay, Monica, can you explain it to everyone, whatever I did explain now, in case you don't have any queries? Yes, Monica, get going.
There's a system.
Once again,
Uh,
yeah, once again, tell me. Yeah, please start again. Yeah.
Hello, can you hear my voice?
Yes, Monica, get going.
Okay. Okay, though there's a system of block of mass m, on which a person is standing.
Right.
He has a mass of small m.
Mm-hmm.
Okay, the whole system is accelerated with an acceleration a,
Mm-hmm.
and there's a force acting on it, and therefore there is an acceleration in the right direction.
Right.
Okay. So what next?
Now.
So the force acting on the man will be in the backward direction, which is called pseudo force.
Mm-hmm.
And this force has the same acceleration as the whole system. It's just that it is in the opposite direction. And the value of the force is equal, the value of the pseudo force is equal to the force given to the system.
Hmm. This is where you're going wrong. See, this F and F naught are not equal to each other. See, once again, the equations of both. Why? Because F naught is equal to mass of the man and acceleration, whereas here F is equal to total mass upon acceleration, man plus platform. Clear, Monica? I will
Yes, sir.
repeat it again for everyone. Class, listen. See, class, what is pseudo force? Simple. We have one block, right? On this block, there is some force acting in the forward direction. But this force is not only acting on the block, of course, it is also acting on everything which is on this block. There might be some boxes kept, there might be U which is standing on it, and so many other things. Let's say their masses is m1 and m2 respectively, right? Let the mass of the entire platform be capital M. So suppose if we are accelerating this entire system in the forward direction with an acceleration a, then individually every object which is kept on this accelerated frame, so this thing will be called as accelerated frame. This thing will be called as an accelerated frame. Now if this accelerated frame is moving in the forward direction, then some force will act on every body which is individually kept on it, right? And each one of them will get an acceleration in the backward direction, which is called A. Now, therefore, force acting on the man will be given as weight of the man, which is m1, into the acceleration, just that this acceleration is same in magnitude as the acceleration of the accelerated frame of reference, that is this one. Its direction is opposite, just that. Similarly, suppose this is block B, all right? So force acting on the block B will be again minus of m2 times of A, right? And these two forces will be called as pseudo force, right? And the net force which is acting on the entire system, of course we know this formula, that net force acting on the system F net is equal to total mass of the system. So how much is the total mass, Monica? m1 plus m2 plus capital M, right, into its acceleration. So everyone please mark that is this force acting on the man is not equal to the net force, but the acceleration of the man is equal to the net acceleration of the system, just that this acceleration is oriented in the backward direction. Only acceleration is same, right? Only acceleration is same for the man and the block which are kept on this frame, right? And just that this acceleration is in the backward direction, right? Monica, now is the concept clear to you?
Yes, sir.
Right? Okay. So this is what is called pseudo force. So class, let us experience this in the form of a question now. In this question, this is what is being told. See here, we have a wedge and the wedge and this block system, and this is the block. We have a wedge and the block. This entire wedge and block system is moving in the forward direction. I will repeat, this entire wedge and block system is moving in the forward direction under the influence of some force F, right? Right, Monica?
Yes, sir.
Now, let us have a look on what is happening. So, suppose this is the wedge, right? Here we'll have something like this. Now it is kept on a smooth surface. So, dear students, in case you're not speaking, please, you may switch off your mics. Right. So, yeah. So once everyone have a look, now this entire block and wedge system is being pulled towards right, let's say with some force F, right? So let us find out what is first the net acceleration of the system backwards. Yes, Monica, can you contribute in this? What is the net acceleration of the system in the forward direction? How do we find it, Monica? Tell me.
It is equal to M upon M naught.
Absolutely. M plus small m, right? Because we are
M
both
plus
are being
M
pushed,
net, right?
right? Clear on this? No confusions, right? Net force is not F by M, Monica. The net force is F upon M plus capital M, because both are being pulled in the forward direction, right? Clear? Pakka?
Yes, sir.
Okay. Now, once we have that this both capital M and small m are being pulled forward, we got the acceleration. Now, what is being asked in the question? The value of force such that this block M does not slide, right? This block M does not slide. So now let us take this angle as theta. Now, as you had said, Monica, let us take the free body diagram of this block M. Yeah. How do we draw it? What all forces are acting? Tell me.
mg downwards.
So we'll take a force mg in the downward direction. Okay, great, excellent. What next?
Normal, which is perpendicular in direction.
Normal reaction. Absolutely correct. We have read about a force called normal reaction, which always acts in the direction normal or perpendicular to the surface. Yes. And something more this time for this particular case. Some special force. Which one, Monica? Yes, Monica. Which force?
Pseudo
Pseudo force,
force.
right? Which has magnitude, mass,
F
small mass
dot
m into acceleration of the system,
acceleration.
right? In the backward direction, right, Monica?
Yes.
Now, let us try to split these into components. How? Which components? So let us take one component. So this is normal reaction N. So see, we all can see that there are three forces acting. One is normal reaction, which is perpendicular to the surface or the incline. The other is pseudo force, which is acting in the backward direction. And the other is mg. We want no slipping to take place, right? Or no sliding to take place. No sliding means this block should not move, right? This one should not move. So when something is not moving, right, it is obviously in an equilibrium state. When something is not moving, it is obviously in an equilibrium state. So how do we get that equilibrium state? So let us draw two directions. One will be parallel to the incline. This one, the black dotted line which I'm drawing, this one is parallel to the incline, whereas the blue line along the normal is perpendicular to the incline, right? Then we will try to take components, right, of both mg and ma. See, so we know that this, let us draw one more. Yeah, this one. Now, Monica, help me with this. How much is this angle given which the incline is making with the horizontal? Theta, right? Therefore, by corresponding angle, this will also be equal to theta, correct? So how about the projections of this MA? How about the projections of this MA? This one will be equal to MA sine theta,
ma sin theta.
right? How about this projection along the incline for MA?
Ma cos theta.
MA cos theta. Excellent, Monica. Excellent. Now tell me, how do I find out the components of MG? See, this is theta, right? So this will also be theta.
This one will be theta.
Now,
Yeah.
therefore, along the incline, this one, along the incline, the component of mg will be mg sine theta, right? Whereas perpendicular to the incline, the component is
mg cos theta.
mg
mg cos theta.
cos theta. Absolutely correct. Right. So yesterday we had understood, right? How do you find components? Just by these angles. So now class, everyone have a look. We have along n. See here, along, this is n, this is the direction of n, right? Just opposite to it, there are two more forces, mg cos theta and ma sin theta acting. Similarly, along the incline, have a look, this is ma cos theta and mg sin theta are acting. Now we all should understand this aspect, that for equilibrium, I'm writing something, for equilibrium or no slipping, for equilibrium, that is no slipping along the incline, what we'll do, equate the forces. Ma,
Equal the forces.
right? Ma cos theta is equal to mg sin theta. Am I correct, Monica? Just cross check. right?
Yeah.
So we'll get A is equal to G tan theta, correct? Right?
Yes.
Now we have one equation of A is equal to F upon M plus small m, and the second equation as A is equal to G tan theta, correct? So we will get, we can equate the two equations, equating 1 and 2,
Yes, sir.
right? Equating 1 and 2. What will be our solution? F by small m plus capital M is equal to G tan theta, right? Now what will this
Uh,
bring us? This will bring us force F is equal to G tan theta
Tan
into
theta
capital M,
M plus.
right?
Mm. Ah,
Monica, once cross-check the entire process that we have followed and explain the question to everyone. Yeah, get going. 2 minutes, get going. Yeah.
okay. So first we'll have to draw the FBD of the system. We'll take the forces.
Mm-hmm. Explain the condition to everyone. What is happening? The force F is pulling the wedge in the block in the forward direction. And we are
Okay.
supposed to find out what is the value of force, what is this force on the condition that this block is not slipping, right? Yeah, get going, get going. First tell the question. Yeah, now proceed. Yes, yes, go ahead.
So we have been asked the value of force for which the small block does not move.
Monica, continue, I'm listening. Yeah,
Hello.
continue, I'm listening to everything. Yeah.
Yeah. So in order to solve this problem, first we'll have to assume that pseudo force is acting in the backward direction, which has the same acceleration as the system.
Mm-hmm. Mm-hmm.
Okay. So we'll find out the acceleration acting on the system, which is F upon capital M plus small m.
Very good.
Okay. So we'll next we will what? Okay.
Simple. We'll draw the free body diagram and then
Yeah,
find
we'll
out.
draw the
Yeah, we'll find out what are the components along the
component.
perpendicular and along the inclined. Because it is given that there is no slipping, we'll equate the forces to get A is equal to G tan theta. We've equated the two equations to get the force, right? Is it clear, Monica?
Yes, sir.
All right. So class, if it is clear to every one of you, please raise your hand so that I know that you are clear with the concept and the question. Yes, class, please get going. Okay, great. So let us move to one more question. Monica, can you please read the next question? Question number 13. This is from the chapter Work by Energy. Thank you, class. You can bring your hands down. Yeah. Yes, Monica, quick.
A mass m of length 2L is allowed to come from A to B.
Mm-hmm.
Find the kinetic energy in position B.
Okay. So what is there? We have some hinge from which a body is hanging, right? Let's say it's a rod, and this rod is first over here, then it tries to come down, right? We leave it from this is the position A, and the central position is position number B. So we allow this mass to come here, right? And its mass is given as m and its length is given as 2l. So it travels angle theta and comes to the base, right? And here you have floor just below it. So what are you being told, Monica? What's the question? What is it asking?
Find the kinetic energy in position B.
During position B. Okay. What should be the approach, Monica, for such questions? What should we understand first? That what is happening in the question? Yeah. From a height, something is coming to no height position, right? Something like that.
Yes.
Tell the approach to the class. How should you go about it?
But actually, I haven't solved this question, but okay.
Yeah, no worries. That's not an issue. But then anything, whatever first comes to your mind, how do you find out kinetic energy in such questions where only this much is given, that the block or the uh, pardon me, the rod was at some angle theta, right? It was allowed to come down and it comes to the position B, right? Under the influence of something. Why does it come down first of all? Tell it to me. Whenever you leave a rod at some position, it tries to come down. Why? Why does this happen first of all? What pulls
Um,
it down? Gravity,
yeah, gravity,
right?
right?
Had gravity not been there, this rod would not have come down, correct? Right?
Hmm.
And we had read yesterday, gravity is what kind of force, Monica?
Conservative force.
Very good. And what happens in a conservative force? What is conserved?
Mechanical energy is conserved.
Mechanical energy is conserved, right? Because gravity is acting on this system and gravity is a conservative force. Therefore, something is conserved, and we are saying that mechanical energy of the system, yeah, of the rod is conserved as it comes, is conserved. Conserved means it remains constant as it comes or as it moves from A to B under the influence of gravity, right? Because gravity is a
Conservative force.
conservative force under the influence of gravity, which is nothing but a conservative force. So because gravity is a conservative force and that conservative force is causing the rod to come from position A to position B, therefore in this process the total mechanical energy is conserved. Therefore potential energy plus kinetic energy will remain constant. That is, at position A, if potential energy was UA, kinetic energy was Ka, their sum will be equal to potential energy at B and kinetic energy at B, right? Am I correct,
Hmm.
Monica? Right?
Yes, sir.
And now we are being told that it is allowed to come. That means at A we can take the potential energy to be the kinetic energy to be equal to 0, right?
Hmm.
Because it is released from this position A, so we can take this as 0. It was not moving, right? Now did it have some potential energy first of all at A, or it did not have potential energy?
It had.
It had. How do you calculate such an energy? See, this is the rod in position A and here is its downward position B. Now let's say this is the floor. Okay, how do you calculate the uh, potential energy of the rod? Yeah, first of all you should know its height above the ground, right? Only then you can find it out. What is potential energy given as, Monica, with respect to the ground?
GH.
mgh. Absolutely correct. See, so now that here this is the thing, this was the initial position A, right? This is the final position B. Let us see what is its height, or and what are we going to consider in both cases? Center of mass. What are we going to
Hmm.
consider, Monica? Center of mass, right? So let's see how far above the ground its center of mass was, right? So we will have this distance. We want to find out how far above the ground this point is, right? This one, right? And then how far below it comes, that is over here, right? We want to find this distance, right?
Yes.
Once we get this distance, we'll be able to find out what is this height, correct?
Yeah.
Right? Now, how do you do it? So, have a look, everyone. Do I know this distance, Monica? 2L, right? Correct?
Okay.
Now, if and I know this distance also, this is also 2L, correct?
Hmm.
Now, let us do one thing. I'll rub these all. So, now, how about this length is 2L, how will this look like? So basically, let us measure it in terms of L as well as 2L. Okay. So first, let us talk just about the center, right? This center is at a distance L from here, and now it is at a distance L from here, right? Now let us take the projection of this over here, right? If this is theta, what will this distance be like? Yes, Monica?
Cos theta.
Yeah, can you repeat again? L cos theta,
L
right?
cos theta.
Absolutely correct. So this is L cos theta, right? So if this is L cos theta, and we know that this distance, because the length of the rod is 2L, so this is equal to L, right? And this is also equal to L. Am I correct?
Yes, sir.
Right? Now, I want to find out how far above the ground this point was. That is this distance, right? I'll draw it with maybe orange, this one, initially. Because I know finally it is at a distance L above the ground, right? Say this is point B and this is point A. So I want to find out first what is the position of the block above the ground, or maybe better to say I want to find out what is the change in the position, right? Only then I'll be able to find out the change in potential energy, right? See here now, everyone, what is happening here? We have UA, right? Correct. UA minus UB is equal to KB from the above equation. Correct, Monica? Right? Right? So suppose this initial height is HA for the point A. Suppose final height is HB. What is the height that we are taking? We are taking the height of the center of mass of the body. How much above the ground center of mass was on the position A, and how much above the ground center of mass is at position B, right? So the difference between them, see here, will be something like this: MHA, MGHA minus MGHB.
Yes.
Right, Monica?
Mhm.
Now, basically, in order to find out your proceed ahead with this question, I will need this value. See, mg, I will need this value mg ha minus hb, right? Correct,
Is
Monica?
it
Which is
uh,
equal to the required kinetic energy. Correct.
KB?
So
Yeah.
kinetic energy at position B will be nothing but mg ha minus hb. Whereas what is ha and hb? Ha is the height
Of
of
mass.
center of
Yeah.
mass initially, right? Height of, both are height of center of mass, but ha is for position A, whereas hb is for position B, right?
Yeah.
So can you try and figure out from the diagram what is hb first of all? L, right, Monica?
Yeah.
So we will have, I'll write it here, hb is equal to L, right? What about ha? First of all, can I find this distance, Monica? Have a look, which I'm drawing with the, which I'm marking with the brown color. This will be equal to L minus L cos
L
theta,
minus L
correct?
cos theta.
Yes, yes. So is nothing but HB or L plus L minus L cos theta, right?
Yeah.
Have a look, class,
L
everyone. I'm talking about this brown colored distance. See, this will be equal to L minus L cos theta, right?
cos theta.
Now subtract HA and then HB. So subtract HB from HA. How much will it be? Of course, one L factor is more. So this will become L minus L cos theta. Right, Monica?
Yes.
Correct. Just substitute it here and you got the answer. Kinetic energy is nothing but mg, whereas
Mg
where mass of the block is given as m, and
M
length is 2L.
to L.
So we'll take this as, and HA minus HB we got L minus L cos theta, right? So where the total length was, how much was the total length, Monica? 2L. You know, for a total length of 2L and for a mass of M, let us substitute. So we had capital M, right? Here L, here G, right? And 1 minus cos theta. So mgl1 minus cos theta is the kinetic energy at the position B. Easy to understand, Monica,
Yes, sir.
right?
Sir.
Clear? Pakka? Now
Yes, sir.
explain it to everyone in one go. Yes.
Okay.
What did we do and why did we do it? Both things. Yeah, get going.
Okay, see, so the rod of mass m and length 2L is being rotated by an angle theta. It does so because of the gravity which is acting on it, and since gravity is a conservative force, so the total mechanical energy of the system remains conserved. Okay, so we'll have to equate the mechanical energies of A and B.
Mm-hmm. Mm-hmm.
So the potential energy of A is mgh.
Yes, you're correct. Get going. Get going. Yeah, you're correct.
So the kinetic energy of the rod A is 0 because it is just allowed to move. The potential energy at B and the kinetic energy at B, okay, is constant. Sir, I don't know how to explain it. Okay.
See, don't worry. Okay. Everyone, have a look. Very simple question. Here, there are two positions. Don't get confused by the complexity of the diagram. It's very, very simple. There was one position, all right, at which there was a rod. This rod moved from this position, which we called as A, to another position, B. And this thing happened under the influence of gravity. It's simple. When this rod was over here, it was not moving, it was steady. So its kinetic energy was zero. But it definitely had some potential energy. So potential energy was not zero at this position, whereas it had some potential energy at position A. How do you find out that potential energy? So in order to find out the potential energy at point A, we considered a point called as center of mass. We wanted to see how far above the ground this center of mass is, right? So we wanted to find this height, all right? Then what did we do is, and what did we do is we took this as HA, right? Then when it comes to position number B, it will definitely have some kinetic energy as well as some potential energy. This is what our understanding is, that at both positions it should have some potential and kinetic energy, right? We are being asked that what is the kinetic energy at position B. So we have taken the center of mass at B and the height of it as HB. Now, we told that since this mass is coming from A to B under the influence of gravity, and because gravity is a conservative force, therefore, the total mechanical energy remains constant. That is, U plus A remains constant. It's constant. And therefore, Ka plus Ua is equal to Kb plus Ub. As simple as this. Now, the value of kinetic energy at A is 0 because it is said that here the system was released from this position or it was at rest. Now, we had to find what is the kinetic energy at B. K at B needs to be found out. So we, from the equation, we got this thing that Kb is nothing but Ua minus Ub. That is difference between potential energy and the position A and the position B. How will you get that? So we substituted it in terms of height. So we got the answer as, see here, everyone, mgha minus mgh b, right? Getting this equation, getting this equation, we found what is the difference between HA and HB in terms of the length. Just that we did and got the answer. See, this length was L, right? So its projection on the vertical will be equal to L cos theta, correct? Right? So its projection on this is L cos theta. We already know that from the projection, let's say this is point O. So the difference or the position difference between O and B is of course L, right? Because this B is the center of the rod which has length L, and this B is L distance above the ground. Very clear? So suppose this projection is coming at a point C over here. So this distance between B and C is nothing but L minus L cos theta, because this is L and this one is L cos theta. See here, this is L cos theta, whereas this entire distance is L. So L minus L cos theta gives us the distance CB. And coincidentally, CB is that distance or the difference between HA and HB. Very simple, right? CB is the difference between HA and HB. Correct? So you can write here this HA and HB is nothing but CB. And CB from the diagram can be seen as L minus L cos theta. So instead of HA minus HB, I have written mg L minus L cos theta, right? And this is how we got the answer, or the value of kinetic energy is given as mg L times of 1 minus cos theta, right? For a rod of mass capital M, so we substituted capital M, right? And its length is given as 2L. So we already have taken length 2L, so we need not take it again. All right. So class, if everyone is clear with this concept, please raise your hand. If everyone is clear with this concept and this question, please raise your hand. Okay, let me check. So we have everyone who is clear. Okay, very simple question, but at the same time, very important when it comes to your examination. Such questions may be asked. Okay, all right. Thank you, class. You can bring your hands down. Another question given to you all was the question of uh, a block of mass M, which is kept on a horizontal surface. See, so everyone have a look. We have a block which is kept on a horizontal surface, right? Which is kept on a horizontal surface. And now we are saying that what is the minimum force which is required to move this block, right? So in order to tackle such questions, let us say the force acting is F, right? The force acting is F. This is M. And this friction on the ground is mu. Suppose this force is acting at an angle theta, right? Now this is the minimum force required. That means there is definitely something which is trying to stop this block, because there is mu. We read yesterday that friction is a force which tries to prevent relative motion. So as the block has a tendency to move in the forward direction, the friction will tend to prevent that motion from happening, or relative motion from happening. So friction will act in the backward direction because some component of force is acting in the forward direction, and that is given or evident as F cos theta. In the upward direction, the component is F sin theta. I can see that. Now we can also see that because it is kept on the ground, so there is definitely some normal reaction from the ground which is obtained, right? Some normal reaction which is obtained from the ground in the upward direction. Let that be N, right? And there is also some weight which must be acting downwards, W, which is equal to mass times of acceleration due to gravity, correct? Now minimum force means the it is we are talking about threshold condition. We are being told what is the minimum force required to move the block, right? What is the minimum force required to move the block? So do you remember I told at the threshold condition, when the force, when this body has just started moving, that means the friction has become maximum. which is also called as limiting friction. That is, the object is going from the static condition into kinetic condition. Class, I will repeat, the object is going from static condition to kinetic condition. Do you remember we had drawn that graph? So what is that limiting force over here? This one is F max, right? This limiting friction is F max between static and kinetic zone, if you all remember. So we have that force of friction given as mu times of normal reaction, right? We know this one relation. Now from the FBD, now from the above FBD, from above free body diagram or FBD, what do we have? Equate the forces. Why are we equating? Remember, because we are just in a starting position. So rather than taking any acceleration, I will assume that the system is in the position of equilibrium, just equilibrium. That means after this, the equilibrium will break. Threshold equilibrium, right? Now, we'll take along the x direction, F cos theta is equal to friction F, and along y direction I can see upward forces are normal reaction F and F sine theta, and the downward forces are equal to mg. Very simple. I have this thing in front of me. After this I can write, everyone have a look. After this I can write, I have to find out F minimum, right? So let us try doing that. We'll find the value of F first. So we have F is equal to small f upon cos theta, where small f is nothing but mu n, we just saw, upon cos theta. Let us find out what is the value of n from this equation. See the second equation which we have just read. Let us take them as three equations. Okay. Now see the second equation. From here, normal reaction will be given as mg minus f sine theta, right? And we have cos theta also on the in the numerator. So that means we need to again do some shifting of variables. So we'll have this, because we want to find out what f is. Our purpose is find out what f is. So we'll make f as subject. So I'll write f cos theta is equal to mu mg minus mu f sine theta, right? And then we will have, taking f on one side, we'll have cos theta plus mu sine theta, right, is equal to mu mg, right? Therefore f is equal to mu mg upon cos theta plus mu sine theta. So I'll write it again, cos theta plus mu sine theta, right? So everybody who is clear until this point of time or this calculation, please raise your hand. Yes, class. I want to see hands raised if you are clear until here, that how did we found out F, right? Now, what is the question? Okay, thank you, class. In case anybody, class, please keep your hands raised. I want to see in case there is anybody remaining. Harsh. Harsh, do you want to ask something? Yes, Harsh, tell me. Okay, I think it's some network error. No worries, no worries. So the point is, if I've got the value of force in terms of mu and theta and mg, now I want to find out minimum value of force, right? Minimum value of force. Any idea? Anyone who would like to suggest how do you minimize F when it is given in function of mu, theta, m and g? Anyone? Please raise your hand. Others may bring it down. Somebody who wants to suggest that how do you find out minimum force may give an idea. Yes, tell me. Rashad. Yes, Rashad, tell me. Yes, Rashad, tell us. Okay, I think everyone has, yeah, Rashad, go ahead.
Oh, sorry, sir. My hand. I couldn't lower my hand.
Yeah, no, okay, yeah. So the point is, in such questions, if you want to minimize f, you'll have to differentiate the f value, right? You'll have to differentiate the f value, right? So let us differentiate it at with respect to theta. So we have f is equal to mu mg whole by, or there is one more technique to it, I'll just tell you all. Mu mg whole by cos theta plus mu sin theta. Now, class, have a look. We are already given in the question that mu is there. We are already given m is there, f is there. What does this mean? That mu is a constant, right? M is also a constant. G is also a constant. What variable remains then? Anyone? Yeah? Anyone? On an obvious note, this theta is a constant, right? And now I want to minimize f, make f is equal to f minimum. So if I want to minimize f, definitely if it is made from one numerator and denominator, numerator is a constant quantity, that means I'll have to maximize the denominator, correct? Only then the entire fraction will be minimized. Let us take denominator as z is equal to cos theta plus mu sin theta, right? What do we have to do? We have to find out what is z maximum, right? What is z maximum? So how will you do it? Simply differentiate it with respect to theta and equate it to 0, because we know that when any function is given, suppose z is given as a function of theta, then at z is equal to z max, at z is equal to z max, the slope of the graph, that is dz by d theta, will be equal to 0. We have read this. Let us apply this. So we'll have dz by d theta from the question equal to minus sine theta plus mu cos theta, right? And that we are equating to 0. So we will have mu cos theta is equal to sine theta, and therefore tan theta is equal to mu. Simple as that, correct? Since tan theta is equal to mu, I can say that from this expression I can find out sine theta and cos theta. See how? Do you remember, class, we had taken up a question when we are given with tan theta, we can always find sine and cos theta by drawing a diagram. I hope you all are able to relate. We have done such kind of question before. So see here, even if you have forgotten, no worries. See here, this is theta, right? We have been given tan theta is mu. Let us take it as mu by 1, perpendicular by base. What will hypotenuse be? Mu square plus 1 under root. From this triangle, tell me what sine theta and cos theta values will look like. Sine theta is equal to perpendicular upon hypotenuse, that is mu upon under root of 1 plus mu square. Similarly, cos theta will be base by hypotenuse, that is 1 upon under root of 1 plus mu square. And these two values you have to substitute in this expression. So these are those values of sine theta and cos theta for which the denominator is becoming maximum and therefore f is becoming minimum. I will repeat, these are those values of sine theta and cos theta for which the denominator is becoming maximum and the entire fraction is becoming minimum, right? Very simple. So we will have f is equal to, I'll write it again, mu mg whole by cos theta, right? This is the limiting condition, class, limiting condition, threshold condition. After this, the block will start moving, right? So as soon as the force is just greater than this value, the entire system will start moving. So we'll have this denominator cos theta. In the denominator, cos theta is 1 by under root of 1 plus mu square plus mu times the sine theta is given as mu by under root of 1 plus mu square, right? We'll take mu under root of 1 plus mu square into mg as the numerator. Then in the denominator, we'll have 1 plus mu square, which 1 plus mu square, and in the numerator, we have under root of 1 plus mu square. So definitely we'll get F minimum. So here what we are finding, what we are getting is F minimum, or the minimum value of F, right? So we have this as the final minimum value of F, mu mg upon 1 plus mu square. A very important derivation class. In exam, you will not be required to derive this, but you will be required to remember this. So this is, I will again mark this as a double starer question and very probable in this year's JEE exam. So please mark this class, please mark this with you. Such questions or such, you might so see in the question we have been given with mu value. In the question we have been given with mu value as 0.5. So all you have to do is just write F minimum is equal to this and then substitute mu is equal to 0.5 if it is given in the question. Suppose M is also given as 1 kg, substitute it. You will get the minimum value of force, right? So see, such an interesting question class. We were not given with any theta. In the question, see, the question is saying what is just the minimum force required to pull a block on a ground where mu is the friction acting. So see, in this question, we just assume that this angle is theta, right? And we tried to find the value of theta, right? We tried to find the value of theta, right? For which this entire expression will become minimum, or basically z will, or the denominator will become maximum. We found that value of theta. See here, we found that value of theta. That theta is nothing but tan inverse of mu. This is that value of theta for which the force is becoming minimum, right? So at this theta, we will pull the block and the block will easily get pulled, and with minimum application of force, and this force will be nothing but mu mg upon under root of 1 plus mu square, right? Okay, if you have understood this question, please raise your hand so that we can move ahead. And in case you have written it down, yeah. So we have Monica, Siddharth, and Mahila with some doubts. Yeah, we'll take them up. Yes. Mahila, tell me. Okay, everyone is done. Okay, all right. Class, do you want me to wait on any page? In case yes, please let me know. Anyone? Please jot down the final result. It is super useful and it is a question which might appear in this year's paper on a high probability basis, right? So class, let us clear the next questions in the coming class today in the evening, right? Thank you everyone. Let us take one simple question based upon pulley system and then continue with rotational motion. So we have, I have a one question here, class, jot it down with you. So the question is, you have a pulley mass system given in the question, something like this. I'll just show. Yeah, have a look. You have a pulley mass system, right? You have a pulley mass system given like this. A man is holding it, right? A man is holding this. So we'll make the man with some different color. He's holding it, and this block. So this pulley mass system is connected to the rope is continued from here, right? The question says, class, listen very carefully. One end of massless rope which passes over a massless and frictionless pulley. So the rope is massless, pulley is also massless. Everything is massless, right? Tied to a hook C, right? So there is some hook through it is tied, while the other end is free. This other end, this second end is free. The maximum tension that the rope can bear, the T max, is given as 360 Newton. you're being told with what value of maximum safe acceleration can a man of 60 kg climb on the rope. I'll repeat, with what maximum acceleration can a man of 60 kg climb on the rope? So this is basically a hook. This is C, right? Okay, I think I have, so I will, this is not a man, this is actually a hook. So here you have a hook here, this way, right? There is a hook here, right? Given in the question, right? And you are being told a man wants to climb from this position, right? A man wants to climb from this position. The man's weight of the man is 60 kg. It is given that mass of the man is 60 kg, right? With what maximum acceleration can he do so if he's climbing on the rope? A very, very beautiful question, class. A beautiful question. You have such questions given in different books also, right? Like one of the books, Concepts of Physics by H.C. Verma, has such questions where monkeys are climbing on the rope, right? And you have to find with what maximum acceleration can they travel. So how do you solve such questions is, you have to draw the free body diagram of man and rope, right? And you will be able to do it. See here. So what is happening when the man is on the rope? When the man is on the rope, right? He has held himself, his legs and his hand on the rope. What is happening? What all forces are acting on the man? The man has held the rope very tightly. Therefore, the rope is a in rope. What kind of force is there, class? Tension force, right? Try remembering. Yesterday I told you all that what kind of force is tension? It is a pulling force. It pulls you, right? So here, if the rope is something like this, right? So the tension along the rope is pulling the man. So you will have the rope is pulling the man upwards with a tension T. Very important, right? And towards the ground, man's weight is acting, that is mg, right? And the man is thus moving upwards. It is thus moving, he's thus moving upwards. So I'll have T minus mg is equal to mass of the man, his mass is m, suppose, right, into his acceleration. Correct? So this is what is happening. We are being told the maximum value of T is equal to 360 Newton. So what will be the maximum value of acceleration? Right? This is being asked. Simple. So we will try to find this out by A max is equal to T minus mg upon m. That is, tension is 360 Newton, maximum tension given. Mass of the man is 60 kg, right? And suppose we take G as 10. So we will have here 600, right? And then divided by 60, right? So yeah, so we'll have this, let us take the value of it, the magnitude. It will come out to be, try it out, this is 600 minus 300, that is 300, minus 60, that is 240. 240 upon 60 will give you 4 meter per second square. So let me check. Yes, the answer is, this is the correct answer. The answer is 4 meter per second square. So class, is everyone clear? I will repeat what is happening. When the man is pulling the rope downwards to climb a pulley, what do we do? We pull it downwards. See here, to climb on a rope, what do? I have to pull it downwards. So as I'm pulling the rope downwards, the rope is pulling me upwards. Remember this. As I'm pulling the rope downwards, the rope is pulling me upwards. Therefore, see here in the question what we have done. And why is it happening? Again, Newton's third law. Every action has an equal and opposite reaction such that the action and reaction both act on different bodies. So I have a pen. I'm trying to pull the pen downwards and the pen is suppose attached to a hook. So suppose this is the hook. Now as I'm trying to pull the pen downwards, the pen is trying to pull my hand upwards. This is what is important, right? Why pulling? Because the force is tension and the tension is a pulling force. We had read. Try recalling. So see, therefore we get here the net tension, right? Tension minus mg is equal to ma, right? And we have therefore ma is equal to tension minus mg upon mass. Therefore, taking the magnitude value of it, we get 600 minus 360 upon 60, giving us 4 meter per second square is the maximum acceleration with which the man can climb the rope, right? So if the question is clear to all of you, please raise your hand so that we can move ahead. Yes, class. Very important, right? Super important question. Also, such kind of question is probable this year. Pulley based question. Right. Thank you, class. So there are such more number of questions, right? I'll be giving you all also, and it's better in case you can solve from some source, and in case you have any queries, you may let me know. Thank you, class. Thank you. So class, let us have a quick introduction to rotational motion before we break for a short break, right? So we have in the concept of rotational motion, initially we see that there is something called as center of mass, etc., right? So the first concept in the entire chapter of rotational motion is center of mass. Whenever there are large number of particles, for this entire system, I can have a point where the entire mass of the system is supposed to be concentrated. I call this point as center of mass. Okay. Now suppose these are different masses of values m1, m2, m3 and so on, and their distances from this point are r1, r2, r3 and so on, right? So we have an equation which says that the position of center of mass is given as summation of each mass into its position. So instead of writing this, I can basically write these are the position vectors of these masses, right? So these are the position vectors of these masses. So let's say the position vector of M1 is R1, position vector of M2 is R2 and so on. Okay. Now, so this is position vector of each whole by the total mass of the system. This is what gives me the position of the center of mass. So position of center of mass will be represented by RCM. See on the diagram, I'm drawing it. This is the position of center of mass. Very simple. We all know that R is given as X I cap plus Y J cap. We had read in the last classes. So we'll just substitute it here. Therefore, equating we get the respective components will be equated and we will get that XCM is equal to summation of MI XI, right, whole by summation of MI, right? Very simple example. Suppose you have such questions are actually asked in the exam. Let's say we have a molecule with two atoms. A molecule with two atoms. Let's say this is atom number 1 and let's say this is atom number 2. Okay. Now their masses are 5m and m respectively. Correct? Now let's say that this 5m is kept on the origin. Right? Red one is x-axis while the blue one is y-axis. Now we are being told find out what is the position of center of mass. So suppose center of mass is lying somewhere over here, right? This is COM, center of mass. Now in order to find out the position of center of mass, what we'll do? Very simple. The same formula, right? Now this, since the entire thing is happening only on the x-axis, there is no talk about the y-axis, so we'll let it go. Now we will have XCM, right? Position of center of mass is equal to M1 X1, where X1 is the position, let's say, of body 1 and X2 is the position of body 2. We have M1 X1 plus M2 X2 whole by M1 plus M2. M1 plus M2. Now, what is the position of this first block? Of course, this position is equal to x1 is equal to 0 because it's lying at the origin. Now, let's say this second block is at a position B. What is the position? B. X is equal to B. Suppose its center is lying at the point X is equal to B. So this x2 is equal to X is equal to B, right? Now we'll substitute it here to get XCM is equal to M1 into 0 plus M2 into B whole by M1 plus M2. Correct? What does this yield us? This yields us M2. M2 is capital M into B whole by capital M plus 5M. Right? M plus 5M. Very simple. So see, this is how we will get the answer is equal to MB upon 6MB. Correct? So this is how, and you can cancel M and you will get the position as B by 6. So we got this as B by 6. Class, what can we conclude from this? That 5M is the heavier mass, right? And this M is a lighter mass. The center of mass of the system is lying closer to the heavier mass because from the other mass, it's, of course, from the graph, it is evident that its position will be 5B by 6. That means 5 times B by 6. So if from one body it is lying at a distance B by 6, from the other body it is lying at a distance 5B by 6. So please have this note with you. The note is center of mass lies closer to heavier part of the system. Heavier part of the system. Center of mass lies closer to heavier part of the system. Class, please note it down. A very important aspect, right? Correct? So it means that the other note is that if you have, let's say, two bodies, right? Two bodies which are of the masses M1 and M2 respectively. Suppose the distance between them is R. Suppose the distance between them is R. So the distance of center of mass from the two bodies will respectively, let us say, given by R1 and R2. Now we have definitely understood that R1 will be equal to R1 will depend on M2. See here, M2 times of, M2 upon M1 plus M2 times of R, whereas R2 is equal to M1 upon M1 plus M2 into R. See this. Now try understanding that see if M2 is higher, M2 is higher, or let us take our case. In our case, suppose this was M1 and the second mass was M2, right? In our case, M1 was higher. See, M1 is higher. M1 is higher, and therefore distance from the second body R2 was higher. See, distance from of the center of mass, that is R2 is higher. Therefore, we understood that R2 is depending upon M1, that is distance of the center of mass from the second body is depending upon mass of the first body, inverse, right? And distance of center of mass from the first body is depending upon mass of the second body. This has to be clear in the mind very clearly. Class, we will now take a short break, right? And we'll be back in 5 minutes. It's 10:33. Let's be back by 10:38. Please jot this down, right? Please jot this down. I'll be sending you all a list of formulas, in your in our group, right? So have a look at those formulas and jot them down with you later, or just keep them for your reference, and make sure that you have those formulas written down in your lecture notes, right? So thank you everyone. Let us break for a short break. We'll be back in 5 minutes, and then let's continue. Yeah. Thank you, class. Also, please do check your notes, right? Thank you. So welcome back all of you. In case you have rejoined the class, please raise your hand so that I'll know that you're present. Yes. In case you have joined back class, please raise your hand so that I know that you're present. Mahila and Rashid, are you there? Please raise your hand, everyone. Mahila, are you there? Back? All right. Let us restart class. So we have the concept of rotational motion given here along with the concept. You can bring your class hands down. So have a look in the group. Have a look at the group. I have sent you all some list of formulas, right, from this chapter. You all have to make sure that these formulas are something you all will be uh, referring to in our class, and they'll also be helpful when you are taking up other revisions, right, for this chapter, or whenever you're solving this chapter. Please keep these formulas with you, right? Now let us start solving the questions, right, based on this formula, and then proceed ahead. So similarly, like this way, this formula was meant when the particles are discrete. This was the case when the particles are discrete. Suppose we have a continuous system. Suppose we have a continuous system. In that case, the center of mass equations change a little bit, and they are given as, for a continuous system, the equations are given as xcm is integral of x dm upon integration of dm, that is sum of all masses. Dm is the small mass, right? And let that be at the position x, right? Similarly, for y and z also, we'll have y dm upon integration of dm. Similarly, zcm will be given as integration of z dm whole by integration dm, right? So these are the formulas. Let us see the application of these in the question, right? So we have one question. Let us take one question from this paper. So I'm taking this paper from taking this question from the year JEE 2019, right? So let's see what the question says. I will want one of you to assist me with this. So any one of you, let's take Mahila this time. Mahila, is your voice, is your uh, audio working properly, Mahila? Everything working good at your end? Hello? Oh, I think she's there in the class. Mahila, can you hear me? I'll unmute you. Yeah, try responding. Yes, Mahila, can you hear me? Okay, no worries. So we'll take up somebody else. Let's take Siddharth this time. So Siddharth, in case you can hear me, can you please, yeah, help? Yes, Siddharth. So,
Yes, sir.
okay. So class, we have been given with a question that we have X and Y axis given in this pattern, right? The question says that there are four particles A, B, C, D, right? A, B, C, D, which are kept on different positions. Let's say one is here, the other is here, third is here, fourth is here. Okay. It says that there are four particles A, B, C, D. I'm naming them here. This is A, right? This is B, this is C, while this is D. It's saying that their masses are A is M, For B, it's 2m. For C, it is equal to 3m. For D, it is equal to 4m. Now, they are kept at the corners of a square. They have accelerations of equal magnitude in the directions as shown. So they have actually shown that these are the directions of acceleration, which I'm drawing with the arrowhead.
Yes, sir.
So I'll take this red arrow to represent the acceleration of each one of them. For D, it is downwards, right? For A, we'll have it as leftwards, exactly leftwards, right? So maybe we'll rub this, right? So now we have been told that if their accelerations are equal in magnitude and their value of acceleration is a for all, the magnitude is a for all,
Yes, sir.
right? And we are told that the acceleration of the center of mass will be acceleration of the center of mass is being asked, right? Now there is one more thing, class. The way just we now wrote this formula, no, so that before you tell the approach, class, have a look at the formulas which I sent you. You'll have this one formula, and how did it get derived? I'm telling you. So we have XCM, right, given as m1 x1 plus m2 x2, right, and so on, whole by m1 plus m2 and so on for n number of particles, right? Now differentiating both sides with respect to t, differentiating both sides with respect to t will give us VCM is equal to m1 v1 plus m2 v2 and so on, right, whole by
Yes, sir.
m1 plus m2 and so on. Similarly, when you differentiate it again, what should you get, Siddharth?
Acceleration.
Acceleration of the center of mass as
Yes, sir.
m1 a1 plus m2 a2 and so on, whole by m1 plus m2 and so on. Yeah. So now, Siddharth, we are supposed to find out in this question what is the acceleration of the center of mass. Yes. How should you go
Of
about
center
it,
of mass,
Siddharth? Yeah. Tell me.
Um. So, first of all, can we use the center of mass of discrete point masses formula to find the center of mass of the given system?
See, Siddharth, for this question, we directly use this formula, ACM. ACM, we have M1 into A1, right?
All
Now,
right.
we'll write
Yes,
M.
sir.
Let's say this is 1, right? So this is particle
Yes, sir.
number 2, this is particle number 3, this is particle number 4,
3 and that's
right?
4.
So now
Yeah.
we have the mass of particle number 1 is M, so we'll write M.
Yes, sir.
But what about its acceleration? Its acceleration is
We
in the
have that also. It's
leftward
A.
direction. So let's say this is
Yes, sir.
X, this is Y, this is X. So something, what is the unit vector along X direction for that?
I
I.
cap. I mean,
Yeah. So what is the unit direction, unit vector along negative X? Minus I.
minus I cap.
Right. So we'll have acceleration as minus A I cap. Am I correct to that?
Yes, sir.
Right. So what next? What next? Tell me the other similarly. What about B? It's
Then for the
2m.
second particle B, it will be 2m.
Its acceleration
J cap.
J cap. Absolutely correct. A into J cap, right? Okay. Now,
Yes, sir.
what about
Then
the third particle? Yes.
it'll be 3m times A I cap.
Absolutely correct. How
Positive.
about the fourth one?
And then it'll be 4m times minus J cap.
Minus
A times minus J cap.
Right.
Yes, sir.
And then you will divide it by total mass, right? So let's
Total mass. So that's 2m plus m plus 3m plus 4m.
So we have
7 plus, so 10m.
Yeah, so we have m plus 2m, 3m plus 3m, 6 plus
4m.
m, that is 10m, right? So in the
10m.
denominator,
Yes, sir.
we'll have 10m, and in the numerator, we can take m and a as common. So we'll have
Yes, sir.
minus I cap, right, plus 2j cap plus 3 I cap minus 4j cap. Am I
minus
correct?
4j cap.
Right?
Yes, sir.
So this should yield you 2 I cap
Uh,
minus 2j cap whole
minus 2j cap.
into A by 10. Am I correct? So that
Yes, sir.
have a
Because that m gets
cross
cancelled.
check. Yeah, just cross check once entire question.
Yes, sir.
Right?
That's correct.
Right? So we
Yeah.
have got, we
And
should
then we
get,
can cancel out the 2
yeah, so we'll get I minus j times of A by
times
5
a by 5
is the net acceleration of the center of,
center of masses.
right?
Mass.
So
Yes, sir.
we'll have A by 5, or we can also write this as A by 5 into I cap minus j cap meter per
Minus j cap.
second square. Right, Siddharth? Clear with this?
Yes, sir. Yes, sir.
So class, I'll repeat. Okay, Siddharth, for everyone's understanding, can you repeat what we did from the beginning and what was also asked? Yes.
So they asked for, so they gave us a system of particles, 4 particles with masses m, 2m, 3m, and 4m.
Right.
And they gave us their positions in space. They were arranged at the corners of a square.
Mm-hmm.
So the question was to find the acceleration of the center of mass of this system.
Uh-huh.
So we used the formula for, we derived the formula for the acceleration of center of mass from the position formula, like differentiate the position to get velocity and then differentiate that to get acceleration.
Right.
And so we know that the formula is going to be m1a1 plus m2a2 plus, until n divided by the sum of the masses.
Absolutely correct. Yes.
So then we found the accelerations, and then we found the accelerations using the unit vector, and the magnitude was given to us as a, and we applied the directions using the unit vectors along the x and y axes. And then we multiplied the masses, and then we substituted them into the formula and got the answer.
Exactly. So class, if this concept is clear to every one of you, that what we did in order to find out net acceleration, all we did was using what are the accelerations already given in the given formula and found out the acceleration. So this diagram was actually given in the question. So in case you're clear with this JEE question class, please raise your hand so that we can move to the next one. Yes. Everyone, please raise your hand if you are clear with the question and the concept and the solution, of course. Yes, class. Okay, so I can see 3 participants raising hands. 4. How about the others? In case you have understood, please raise your hands, class. Okay, right. Siddharth, have you understood it very well?
Yes, sir.
Okay, right. So now let us take next concept. Thank you, Siddharth. Right. So yeah.
Thank you, sir.
All right, class. So class, let's have look at the another aspect of the chapter. Very important, right? And very crucial at the same time. Whenever a body is undergoing rotational motion, whenever the body is undergoing rotational motion, we have some variables that come into play. And those variables are, just like we had 3 equations, with kinematics, 3 kinematic equations for linear acceleration, for linear motion. In rotational motion also, we have 3 kinematic equations. See here, class. I hope you all remember this. So we had V is equal to U plus AT, right? There we used to talk about linear velocity. Here we will talk about rotational or rotational velocity, right? Or angular velocity. So we'll call that as omega, right? Initial angular velocity will be called as omega naught, just like U. Instead of acceleration, now we'll talk about angular acceleration. So we'll call that as alpha. Everything else remains same. The setting of the variables remains same. Just that we are developing a rotational analog, right? We are developing a rotational analog. Things very same. Similarly, you have S is equal to ut plus half at square. Then you have here, you will have, instead of S, you will have theta. So here S used to be linear displacement. This theta will be called as angular displacement. What is it called as? Angular. Everything is now angular, right? this is instead of writing ut, you will write omega naught t plus half alpha t square. Similarly, here we have next equation as v square is equal to u square plus 2as. So instead of that, we'll have another equation given as omega square is equal to omega naught square plus 2 alpha s, right? So this is what you all have to remember. So class, talking about the distribution of these chapters, which we have read in this class, in the last class, every year around 4 or 3 questions, mostly 4 questions are asked from rotational motion. Also, the chapter which we just read uh, had like the 2 chapters. From each chapter, you get at least 1 or 2 questions each, right? So let's say in 2002, right, in AIEEE exam, we had at least 4 questions that were asked from kinematics, right? And then from laws of motion, you had at least, again, from laws of motion, you had, I am very much flabbergasted to see 7 questions which were asked from just one chapter, 7 or 8 questions, right? So please make sure that this laws of motion is very, very strong at your end. There might be other batches, they might have been asked in batches, but yes, I can see that from laws of motion, they have given it a huge importance. More than 4 to 5 questions were asked from these chapters, laws of motion, right? And then even in work power energy, if I see this year's paper, right? So if I talk about JEE NEET 2019, you had questions appearing around 1 or 2 questions from work power energy, right? And from laws of motion, good number of questions are asked. That is why we have given it so much amount of time. So, right now, that is why we gave it that much amount of time. Even rotational motion has keeps a good importance. Around 4, sometimes 5 questions are asked in one paper, right? So yeah. So class, let's continue. You have these 3 equations. Like the way these linear equations were valid only when acceleration is constant, linear acceleration. Similarly, these equations are valid. So the condition for validity of these equations is that alpha should be constant or angular acceleration should be constant. Please note it down, class. Angular acceleration should be constant, right? So these are some things that you should know, right? Quickly transiting to the next part, that is the way we used to have translational equilibrium, and we used to say F net is equal to 0. Similarly, here you have rotational equilibrium. Instead of having a force, here we have a term called torque. You all must be aware with it, tau, right? Which is equal to 0 when there is rotational equilibrium. So the condition, these are condition for equilibrium, right? In order to define it even more properly, let us write this over here, right? So we have this expression like the way we used to define F is equal to ma, right? Where mass, this was acceleration. We define tau or torque given as cross product of position vector of the point and the force which is acting at that point, right? Similarly, we also have tau, the magnitude or its value, given as I into alpha, and this is mostly used when the axis of rotation is fixed, when the axis of rotation is not changing. Then we can use the formula tau is equal to I alpha, where I is called as moment of inertia. The way we used to have mass, right? Mass as the representation of inertia, right? In linear motion. Here for rotational motion, we have moment of inertia given as I. which not only depends upon mass, but it depends upon the distribution of mass. Very important. This is called as moment of inertia, right? It keeps the same importance for rotational motion, the way mass kept for linear motion. So we have this depends upon the distribution of mass, correct? For a discrete body system, M has M has value given by summation mi square, right? This is how you give moment of inertia for a discrete mass system. And when you talk about for moment of inertia for a system which is continuous in nature, then you just have, instead of this, integral r square dm, right? This is moment of inertia for a continuous system. So this was for a discrete system, whereas this is moment of inertia for a continuous system. Everyone kindly jotted this down in your copies, right? So you have several such good questions which are asked from these concepts. So let us take them one by one, right? So let us see if I have a question for you all from the past year papers, right? Yeah, all right. So you all should be aware with this concept, right? Also, I hope you all are very well aware with the parallel and perpendicular axis theorem, right? Parallel axis theorem states that if you have a body, something like this, right? And you know the moment of inertia of the body, which we just discussed about its, which is axis, which is passing through center of mass. I will repeat, for a body, if you know the moment of inertia through an axis which is passing, like via an axis which is passing through center of mass, you can find out moment of inertia through any axis which is parallel to this axis. Let's say this parallel axis is at a distance of r. So you will have moment of inertia via this new axis is the sum of the moment of inertia via the axis through center of mass plus mass of the body times of r square, where r is the perpendicular distance. It is r is the perpendicular distance between the two axes, right? Similarly, perpendicular axis theorem is given by, let's say I have a plane lamina, and I have two mutually perpendicular axes passing through center of mass, right? And the moment of inertia through each one of them is I1 and I2 respectively. Suppose now I am taking another axis, let's say this one, the one which is marked in red, right? And I want to find out the moment of inertia through this dotted axis, right? So this moment of inertia I will be given as simply sum of I1 and I2. I will repeat, the I1 and I2 are mutually perpendicular to each other, right? The two axes. And this axis, the one which I've drawn with red, is perpendicular to both of them, right? Is perpendicular to both of the two axes, and the moment of inertia through this red axis is given by sum of moment of inertia through the two axes, right, which are lying on the plane of the plane lamina, whereas this red axis is perpendicular to that plane. Very important. That is why this theorem is called parallel axis theorem, right? So I hope you all are clear with these definitions. This was just a quick revision. If you'll recall, in one of the classes where we were reading about two-dimensional motion, we had calculated angular momentum of the ball at its highest position, right? So that angular momentum m is given as r cross v, r cross v, right? Similarly, the way we used to write here, that f is equal to rate of change of linear momentum, we write here for the rotational part is torque is equal to rate of change of angular momentum, right? Where L is the angular momentum given as cross product of R and P. R cross P is called as angular momentum. Please jot this down, class, with you. After understanding all of this, there is one very special part of the chapter which talks about rolling motion. What is rolling motion? Rolling motion is a combination of translational and rotational motion. Rolling motion is a combination of translational and rotational motion. Suppose I have a body, right, which is translating ahead as well as it is rotating, right? We will, if we combine the two motions, what we get is rotational motion. So suppose a body is moving with forward direction with a velocity vcm. That means every part of the body is moving with the same velocity vcm ahead, right? Every part of it has a translational velocity in the forward direction, whichever point you talk about, right? Let's say this is point A, B, right? Point C, point D, or the center. But if you talk about rotational motion, class, the concept becomes a little different. Here, the body is rotating, right, with an angular velocity omega. So the rotation is constant, or angular velocity same for all the particles. I will repeat, omega is same for all particles. Is for same for all particles, but very important, because of this rotational component of velocity, there is something called as linear velocity, which is nothing but r omega, where r is the distance of that point for which I'm trying to find out the linear velocity. Let's say we'll take a random point, or over here, let's talk about this point, okay, point B, on this body. Now, if the point B is at a distance r from the center, because of the rotational motion, which is giving it an angular velocity of omega about the origin or the center point, it also has a linear velocity which is given by r omega, where r is the distance. So if I'm talking about some other point, let's say here b dash, which is now at a distance not r but r by 2 from the center. So this b dash point will have a velocity in the forward direction given as r by 2 omega, whereas b has a velocity r omega. What have we understood? We have understood that because of the rotational motion, if there is a linear velocity, that depends on the distance. Very important. Whereas here in the translational motion, the linear velocity was constant for all particles. Here, the linear velocity is constant and same for all particles. Instead of constant, I think the better word is same. Linear velocity is same for all particles. Whereas in rotational motion, the linear velocity due to rotation depends on distance. Very important. This is the point of difference where many students require knowledge, right? So linear velocity due to rotation depends on distance from the axis of rotation. Like here, this distance was r by 2, right? Therefore, the value was r by 2 omega, whereas this distance is r, therefore value is r omega for the linear velocity, right? This was r by 2, whereas this distance was equal to r from the center or from the axis of rotation, right? This is the point of difference, class. This is how a rolling motion is constituted. So suppose when we are talking about a pure rolling motion, in a pure rolling motion, we are basically combining the two, right? And now, suppose the two are combined, that is, the body is rotating as well as it is translating. When this phenomena is happening, we will combine these values and now we will have something like this. Have a look. I am drawing with green color the linear component of velocities. Have a look. It's same for all particles and equal to, let's say, V naught, right? In pure rolling, what happens is this V naught is becoming equal to R into omega, where in fact R is radius of the body. Very important. What is happening in pure rolling? The linear velocity or VCM is becoming equal to R omega. So let's say this was R omega. Now we will talk about the linear component of velocity due to translational. Let me denote it by this red arrow, right? So for this point, now I'm naming the points class. Again, this is A, B, C, and D, and this is O. Remember and listen very carefully. Very beautiful concept this is. So we have at point B, the linear component of velocity is V naught at every point because of translational, right? Now let us bring rotational also into this aspect. Let us say this body is also rotating while going ahead, right? That is, this is rolling in pure format. So because of rolling, what is happening is every point, now see, every point is getting a velocity in the translational direction also. See here, this red direction is telling how will the particle be moving if the body is rotating. See here in this direction, right? This is how will be the instantaneous velocities of the particles A, B, C, D if the body is rotating, right? And it will again be V naught, V naught, V naught, and V naught. Why have I written it V naught? Because coincidentally, for a rotational motion, the VCM is becoming equal to R omega, right? So what will be the net velocity of the point A? Or let us start it from point B, which is at the top. For point B, it will be 2V naught, the net velocity, right? 2V naught. Let me draw it with a separate color. Let's say blue. So we have net velocity of point B is 2V naught. One is because of rotational, the other is because of translational. Similarly, for point C, have a look. Here we have V naught and V naught perpendicular to each other. So net will be, we have just read in the last class, whenever we have two components of velocity directed perpendicular to each other, we'll find out their net value by parallelogram law, and it will come out to be V naught root 2, right? V naught square plus V naught square under root, because the angle between them is 90. One is horizontal, the other is vertical downwards. So we'll have V naught root 2 is the velocity for point C. For point D, what is happening? See, one velocity is ahead, the other is behind, and both are equal to each other. So the net velocity of point D becomes 0. Similarly, velocity of point A is equal to V naught root 2, right? Velocity of point B is equal to, we already have read above, it is equal to 2V naught. I hope this concept is clear to all of you. If yes, please raise your hand. All right. So thank you everyone for attending this session, right? So I have given you two other formulas also, right? The value of kinetic energy, rotational and linear. So suppose we write the linear kinetic energy is equal to half mv square, right? Let us say this as kl, and we can also call it as translational. So we can call it as kt, or the translational aspect of kinetic energy. Then there is rotational aspect of kinetic energy given as half I omega square. Half I omega square. So the total kinetic energy K is the sum of translational and rotational given as half mv square plus half I omega square, right? If V is equal to R omega, right? Or suppose there is one term defined as K, it is called as radius of gyration. Radius of gyration. We define this as, suppose total moment of inertia of the body is I, its total mass is m, and if we write I is equal to mk square, then K will be called as radius of gyration, right? Now, in this expression, suppose we write V is equal to, in this expression, we'll take V is equal to R omega first. So let's do that. So this will become R square omega square. And instead of I am writing mk square. Correct? So we will have the expression. Let's take half and m common. So this was capital M on both sides and omega square also common. So we have a look, plus this will become R square plus K square, right? Is the value of total kinetic energy. This is kinetic energy. Total kinetic energy. Or instead of omega, let us substitute now. Instead of omega, let us write V by R and see what happens. Half m V square by R square plus K square. This becomes half mv square, right? 1 plus K square upon R square. Correct? So this is the value of total kinetic energy, right? Total kinetic energy. So class, I'll be giving you all some questions, right? Based on the based on the formulas which I've sent you all and whatever we have discussed today, right? I'm sending you all some questions. Solve them, right? And let us discuss them all today in the evening session, right? So this is how we have learned today. A quick revision, right? We had decided to go for some questions, some remaining questions. Please remind me, which we'll take up in today's class. Pulley based questions and rotational motion and system of particles. We understood about pseudo force. We understood that how does the pseudo force acts. We also saw how conservative forces act and make sure that mechanical energy is conserved. We also saw this question where the net force had to be calculated for in order to move a block. We found it was mu mg upon under root 1 plus mu square. Then we saw how if a man is moving on a pulley, how will we calculate its maximum acceleration. Then we saw some very beautiful facts about center of mass, right? Then we saw how we'll calculate uh, acceleration of center of mass and velocity of center of mass. Both are beautiful formulas. We saw kinematic equations in rotational aspect and understanding. We developed once again the understanding of tau and moment of inertia, etc. Right? We saw what is pure rolling and how do you understand the velocity of each point, which is nothing but the sum of velocities due to translational and rotational motion. Then we understood how do you write total kinetic energy, right? And this is how class we came to terms with this. So these are some beautiful formulas. Please note that a body which is rolling down an inclined plane, a body which is rolling down an inclined plane of inclination theta, it has radius r, right? And it has circular cross section. It can be a cylinder, it can be a ring, right? It can be a sphere. It will have different values of k square by r square, right? So let us write different values of k square by r square with us before we solve the question today in the assignment class, right? So here you have different values of k square by r square for different objects. So let's say here we are writing about different objects, and here we have k square by r square values. For a ring, k square by r square is 1, right? For a sphere, solid sphere, rather let's write solid sphere. So for a solid sphere, this value is 2 by 5. For a hollow sphere, this value is 2 by 3. And for a cylinder, which is hollow, right, it is 1. For a solid cylinder, for a solid cylinder, this value is half. Similarly, let's take a disk. Right? Now let's take a disk, a solid disk, right? So for a disk also, this value is given as half, right? So these are some examples of k square by r square value. Suppose now this kind of one of these bodies is rolling down an inclined plane which has some friction, right? So one of the necessary condition for rolling is that there must be friction. There must be friction present on the ground. Without friction, rolling cannot take place. Very important. So here there is some friction. It is not smooth. So at any point of time, if I want to find out what is the linear acceleration of this block downwards, so that linear acceleration A will be given as g sine theta upon v upon 1 plus k square by r square. What does this mean? If k square by r square value is less, that means the acceleration will be high. So the velocity of reaching downwards will be high. So if anything is going with high velocity, that means it will take less time, right? So for all of these questions, we can get different questions that let's say a ring and a solid sphere is allowed to roll and find out in how much time, or find out which one will reach early, which one will reach later, right? So for such questions, we use this approach, right? I hope this concept is clear to all of you, right? So thank you everyone for attending the class. I'll send you some questions which are based on these aspects and we'll discuss them accordingly. Before we leave, are there any queries, any doubts at your end? Please let me know. Yes. Anyone? Siddharth or Mahila, you want to ask something? Okay. Okay. All right. So thank you everyone. Let us meet
Thank you, sir.
today in the evening class, right? Thank you. Let us meet in the evening class and we'll discuss some assignment questions where which will be based upon these fundas which we have read today, right? We'll practice them with some questions. I think we had some previous questions also, right? Dimensions, we had to read significant figures, dimensions, screw gauge. We'll take up those questions as soon as we are completing the already assigned tasks, right? So in today's class, rotational practice in the evening, assignments will be sent to you all, right? Thank you everyone. Thanks a lot.
So
Thank you. Thank you, class.